to close Unit 7 on confidence intervals, we will calculate the sample size n of a sample if we know the specific margin of error for the population proportion that we are okay to accept, and the confidence level, obviously. So if you remember, the error bound for the proportion or margin of error for the proportion equals to z alpha halves times the standard error, which is p hat times q hat divided by n. If we solve this for n, the formula will be z squared times p hat times q hat divided by the error. And actually the error squared, I should have said here. And this formula is also available in your final exam formula packet. Here for the sample size, the first formula we used previously was for the mean, and here is the formula for the standard deviation, which is not exactly yet what we have discussed, because in reality, if we already knew the sample, we would have done our survey and we would know the p hat and the q hat. So before we start our survey, we don't know the p hat and the q hat. And if that is the case, then we want to just maximize the number of the possible way that errors could happen. And to do that, we have to maximize the product p hat with q hat, and it is maximum when they are both equal to 50%. If that is the case, 50% times 50% in the numerator will be 0.25, and therefore we have the formula for n to equal 0.25 times z squared divided by the margin of error for the proportion. The z score, if you remember, is determined by the confidence level. And to remind you how to find it, we used the normal distribution app here. So when we are in the normal distribution, we want to find the percentile quantile. We want to leave it as a standard normal distribution with a mean of 0 and a standard deviation of 1. We want a central interval, so two-tailed, and based on the confidence level, the 90% will give us the z-score of 1.645, the 95% will give us the z-score of 1.96, the 98% will give us a z-score of 2.326, and the 99% will give us 2.576, and so on. So if you are looking to do this manually, you will need to find the z-score based on your confidence level, and you want to use this app, the normal distribution, to find your value. So let's try to solve a problem. Suppose a mobile phone company wants to determine the current percentage of customers aged 50 plus who use text messaging on their cell phones. How many customers? That's the question. What's the N? Should the company survey in order to have a 90% confidence that the estimated sample proportion is within 3 percentage points of the true population proportion? So the error bound for the proportion or margin of error needs to be plus or minus 0.3. The confidence level of 90% gives me a z alpha halves of 1.645. And therefore, to find the n, I would just calculate 0.25 times the z-score squared divided by the error squared. I wrote it incorrectly. 3% is 0.03 and not 0.3. 0.3 is 30%. So when I do this math, it comes out to be 751 0.67. I always have to round up, regardless of what the decimal part is. So 752 would be customers. Would be the number of customers that the company will want to survey. And again, if you use the inference for the proportion, for the population proportion app, it does have a find the sample size tab. So it says, what do you want the desired confidence level to be? And I want it to be 90. And what do you want the margin of error to be? And I want it to be 3%. And it tells me that 752 will be the desired sample size. So I didn't have to do the math. Let's try to do one without doing the math. Suppose an internet marketing company wants to determine the current percentage of customers who click on ads on their smartphones. How many customers should the company survey in order to be 90% confident that the estimated proportion is within 5 percentage points? If I use the formula, the z-score, the z-alpha halves will be 1.645. This is determined by the confidence level of 90%. And the error bound for the proportion or margin of error for the proportion will be 0.05. And then I will plug it in the formula, 0.25 times 1.645 squared times 0.05. I will find it to be 270.6, and I will round up to 271. Alternatively, I will not do any math and I will just use the technology. The technology says if I want to be 90% confident with a margin of error of 5%, then I'm gonna ask 271 people this particular question that I'm trying to investigate, the true population proportion of. Let's refresh our memory. What was the glossary for section 7.3 on the confidence interval for the true population proportion? We talked about the binomial probability distribution and we reviewed this, and then the error bound for the proportion as the margin of error also for the proportion, and the formula for how to find it, which is also in our final exam packet. We talked about p hat or p prime, which is the proportion in the sample, and that is the statistic, and it is an estimation of the population parameter that is denoted with p and in some books with pi, not in our book. And then we discussed the +4 method that is most effective for smaller samples, which generates a little more accurate results and also a smaller margin of error.